All right. Should be good to go. Let's turn this music down a bit. So, I've figured out some of the issues that we were having before. Oh, damn, that's some crazy ass hair. I figured out some of the issues that we were having before. So if you didn't join for the last stream, let me get everything pulled up. Tell me that. If you weren't here for the last stream, we built our dropper. Our dropper was dropping, but because there were some issues that I'll go into in a second, our dropper was dropping an executable that was like 2 times the size it should be. Thought at first that it was an encoding problem over the wire. Found out that was not the problem. I did not really know what was going on until I asked for some help in another sharing group. And when I chatted with them, they said that newer versions of PowerShell will default to Unicode. So it was basically dropping the Unicode version of our executable instead of the ASCII version. Well, Unicode is, I think, exactly twice the size of ASCII, so that was causing our problem. Now, we've got the correct size executables. Let me go ahead and switch over to the screen recording. We've got the correct size executables. What we don't have is working executables. So they'll work here. We can go to, let's see, C2, data. We can run it here, and we're good. Obviously, this is just a simple hello world script, but eventually it'll be something cooler. That's going to be what we work on today, if we can figure out the real next problem, which is compilation. Now, I am using MinGW, which is the GCC compiler for Windows, and that defaults to compiling in 32-bit mode, which is having issues with our 64-bit virtual machine. Plus, it's easier to compile to 32-bit and make portable malware because 32-bit, like, no. I'm saying it the opposite way. Eventually, we do need to figure out how to compile in 32-bit and have it work everywhere. And I believe, yeah, so the way that's going to end up working is basically, ooh, that's a lot of files. Looking over here at the other compiler, which is MinGW 64, which is the 64-bit version of GCC for Windows. So basically, I'm going to change the name of this, 64. That should be fine. Basically, the way this should work is I should be able to now open up a new version of Commander. Or not? Question mark? Oh, this is in my VM. That's why. Commander. So I should be able to open up a new version of Commander. Should have had my path set up correctly. GCC 64 version. Yep, okay. So we've got GCC 64, and the target should be 64-bit Windows. So it's actually x86 64, which is exactly what we need it to be. If we look at GCC-V, this is MinGW 32, so that's just a 32-bit file. We want x86_64 because that should work on 32-bit machines and 64-bit machines. So let's go back to our makefile. Theoretically, this should be done. I'm also going to walk through a couple of changes that I made to my makefile. I was dealing with some issues basically in like automating, copying things over and all of that fun stuff. Basically what I want it to do is I want it to make all of this stuff. And I've already gone through how make works, but I want to make all of this stuff and then copy over the new executable to the data directory so that I can basically automate fetching it with my dropper. Theoretically should work fine. Did my stream restart randomly? Kind of looks like it did, but it may not have, I don't know. Definitely looks like it did. That's weird. Okay, so basically what this does is it makes everything, and then it will run the copy.bat file, which is just a batch file that will delete the old version of main.exe and the data directory, which is where C2 is hosting our executable, and then it will copy the new version over. Simple as. Then the clean will just basically delete everything. So it'll change into the directory that we want to delete from, and then delete all of the xe's and all of the o's. Simple. So I'm going to run make clean. And what we need to do now is change this over to GCC 64, change this over to GCC 64, and this should still work. Fingers crossed. Let's go ahead, I'll go ahead and demonstrate this part at least works. We're gonna delete the main file from the directory. We're gonna make, and we have nothing. Cool. That's weird. Should be able to get rid of that. Okay, so this is an old terminal. That might be part of the problem. Let me kill that terminal. That terminal should be fine to stay open. We're gonna split this over. We'll actually, instead of creating a PowerShell terminal, we will create a command terminal. Shouldn't matter, but let's see, command prompt, GCC 64-B. No, it does not recognize it, which is interesting. Huh. So I might have to restart Visual Studio because I did update my path. So let me restart VS Code. VS Code. Open that back up. Hopefully, yep, open up the right file. Probably killed our C2, which is okay. Let's see, CDC2, Unicorn, it's app, and we want it on, let's see, what's our IP? Host 92.168.156. Port should be fine. I believe I'm using port 8000 on that anyways. Let me make sure. We are getting it just from 80. Okay, so I do need to change the port. Right, run that. Running on 80 now. All right, so now we should be able to run GCC 64-B. Yep, that works. And let's run make. All right, we're building. We've got an output. And we've got an output there. Okay, so now we've got what should be a 64-bit executable sitting in data. Let's snag it. Successfully grabbed it. Let's pop over here. We'll actually use the command prompt. And we should be able to just run clearly mal. Moment of truth. Nope, did not work. Shit. Huh. So that time it definitely should have worked. Let's delete, run again. Yeah, sure doesn't work, does it? Let's just try running it with the 64-bit flags. So let's do -m64. See if that works. Make clean. Make again. That should have deleted right version, but we're just gonna check. Again. All right, let's go back to our VM, clear this out, run it. Nope. That sure isn't working. Wrong one. So, huh. I wonder why it's not working. I mean, these are identical. I might have to pop open a PE Explorer. Let's see if I've got it on here already. Probably have to download that shit again. So there's something funky going on where it ain't working. At all. Let's change the encoding again, just to kind of play around with it. I'm not going to spend a ton of time on this tonight because it kind of took up all of the time for the last stream and that was kind of boring. So GCC 64 should be building 64-V. So it's building for x86, x64. Oh, that's so much shit. 64-target help. We're going to output that to target-help.txt. You can read it a little bit easier. Now, we could try it with 32-bit and see if that works. That couldn't hurt. I mean, that's the only thing I really haven't tried. We're gonna try this, and then we're gonna try one more thing. So let's make clean, make, what the hell? That didn't work. I had some kind of issues with that. What in the world? All right, let's clear this out. 32. We'll pipe the output to air.txt. So it's having some kind of issue. It must be with that 32-bit flag, I bet. Not even checking chat right now, got hidden. There we go. Arzu, can't see anything font size too far. People should see code. If you want to develop malware, you should take other people's code to try to recreate it and put a lot of comments around the code so you know what the code does. Disagree, but we are going to talk about that soon. I think reading other people's code can be super helpful. I think it can only take you so far, though. Basically, if so I agree that reading code can help. I disagree that that's the only way or even necessarily a good way. Only because I think the best way to kind of learn code is to actually do it yourself. If you spend too much time reading over people's code, you'll become a master at reading over people's code and changing it and commenting it and things like that, and you're not going to learn that much. I say that as somebody who used to learn that way. I used to read a ton of people's code, and it just, to me at least, it ended up kind of slowing me down a little bit. So let's see if, let me make sure that main.exe will run on my PC. So we're going to go to It'll be in documents / RE stuff. Wolf 2.0. Let's run main.exe. Works on our PC. We're on a 64-bit PC. Does not run on the VM. Ah, that's annoying. So let's go ahead and download sysinternals. And that's a 45 meg folder now. That's wild. But we do need it. So let's extract all of this into PC, program files, sysinternals, and just yoink all that over. That should work. We're just trying to create new boiling water. Oh, I forgot to read your other message. Agreed, but initially my point is that you shouldn't just read it, you should recreate it and fully understand it. And the thing is, we're engineering malware, so everything is already created. Yeah? So certainly the stuff that I'm doing is nothing new. Let's see, path. But here's the thing. There is new stuff coming out. There's new ways to do things, and you might be doing the same thing, but you're doing it in a unique way, which in itself, I mean, it's not necessarily useful as like somebody who's operating malware, but it's super useful as somebody who's researching malware, if that makes sense. Somebody who's operating malware, it's not as cool or fun or interesting to just do new things in new ways for the sake of doing new things in new ways. Like, that's not really your job. As a malware researcher who does things the way that I do, like reverse engineering, who like writes malware to learn more about malware, that's kind of the whole purpose. Let's see, it's PE Explorer? PE Bear? Can't remember the name of it. Let's see. But, you know, like I said, it can be super useful to like learn things, basically to learn things by reading other people's code. And like, that's what most reverse engineers do for malware. It's like they kind of learn malware through other malware. But there are new things that you can do and new ways that you can do new things. And sometimes if you take the approach that I do by like building malware, you can build things in a way that like it becomes, I don't know, it's hard to explain. It becomes super useful just because you're learning ways that it could be done, and that way that it could be done might end up being used someday for whatever reason. So I don't know if that makes sense at all, but that's kind of like one of my bigger purposes. I forgot how to just do this. Okay, so here's how we're gonna do it. Let's copy it from here. This is such a dumb, stupid, dumb thing I can do. We're gonna just straight up copy it. We're not gonna worry about like the dropper. We're just gonna run it like this. So it works that way. So it's an encoding problem, is what it is. So it's 58 kilobytes here. And let's go back to the dropper, run the dropper. Now let's see what size it is here. And honestly, I might just diff it. So here it is 59,017 bytes. Here is 59,015 bytes. we are missing 2 bytes. That's wild. What 2 bytes could that be? Oh, wait. Mahad, what's up, man? How's it going? I get your point, but like my malware was like this. I created my socket and copied snippets of code from GitHub, and of course, I know what those snippets does, but simply with that, I learned a lot. Yeah, so the basics, like you were saying, and I think we both agree, you and I do, Luca, is basically like the basic stuff you can do fairly easily by just like copying and understanding how it works. So like socket, like conversation. Socket conversation, really, it's like the same. You know, it's all essentially the same. You're kind of just communicating across sockets. There are different ways that you can do it. You might can write, you know, like really complicated shit, but like at the end of the day, it's a socket talking to a socket. You know, like Windows API and when to use which in which scenarios. Yeah, exactly. So the way that I call the Windows API function and the way that you call it is probably the same. So yeah, I agree. That stuff you can basically copy paste over. What I think is different is like the bigger picture of how all of that stuff works, like the system that you're building to actually do all of this stuff. You know, so yeah, you can copy paste snippets. Now, even with copying and pasting those snippets, it is fairly useful to understand how those work so well that you can like copy paste it from brain instead of like having to find it on Stack Overflow or whatever. But I think you do agree with that as well. So, 1 second. Got this one right here. That is the correct version that will run. That one is 2 bytes smaller than this one. Now, do we have the diff command? We do not. Huh. Let's just copy this one over as a text file. See what we can see. So this is now a text document. It should be same size, 59,017 bytes. This one is 59,015 bytes. So let's see if we can see anything that might be causing that 2 byte difference. They're like okay, Mahad, you're here. So I found out one of the issues. One of the issues is that the new version of PowerShell automatically outputs files in Unicode unless you tell it to output it in ASCII, which is lame. So that immediately solved like the file differential problem. Now we have got 2 extra bytes on our copy for some reason, and I just can't. Do we have bin diff? Ooh, that was almost bad. Let's see if we've got bin diff somewhere. Bin diff. No, don't. So let's see if we can get bin diff on Windows. Bin diff. Let's see. Dynamics, is that where it comes from? Yeah. So that should be it. No, that's a little bit more than what we need. We just need Windows. Let's just use diff. Yesterday, I've coded a simple payload in ASM and converted it to base64, then downloaded and executed it using PowerShell, using write all bytes, and it works fine. So again, it's a really weird issue now. Oh my gosh, what the hell? That's ridiculous. It's a really weird one. Okay, so it's FC. Yeah. So FC / main.exe and /.temp. Yeah, no. What's it called? So now it's a weird one. Now our issue is that the file being dropped is 2 bytes, literally 2 bytes larger than the real one, which makes 0 sense. Like, completely 0 sense. It's the correct encoding. We know that now. B64 ASCII.exe. Not open what? fc main.exe and temp clearly mel underscore b64 underscore ASCII.exe. Well, that's like, yes, I know it's longer. So what if we did this? Like this, just, that's the least helpful thing possible. And output it to def. Now let's do notepad def. All right, comparing files main.exe. You tried to deliver the file without encrypting from the Python gateway and write it directly to the disk. And check if it's a valid PE file. So yeah, that's basically what we've done here. So this version right here on desktop, if we go to desktop, this is literally just copied over, and this works. So if we go back here and run main.exe, this works fine. If we go to .temp and run clearly mal, it does not work because there are 2 extra bytes on clearly mal, the version that we copied over. And I just have no idea where those 2 bytes are coming from. Like none. I'm thinking, let's just go in here and I'm just gonna do something real dumb. It's only dumb if it doesn't work. We're just gonna remove this line. Then we're going to save it, not as a .text, but as a .exe. So, we've saved it as a .exe. This right here should work. If that was the correct thing to do. I have no idea if that was the correct thing to do. No, it was not. Oh, that's so annoying. So we've got a copy-pasted version that works. We've got a not copy-pasted version that does not work. If we look at this one now, so now it's the same size. That was not the bytes that I needed to remove. So that versus that. No, it's not the same size. So I didn't remove enough bytes. Let's just, I mean, we can keep trying here. There's just somewhere in here that there's 2 bytes that don't belong. That might be it. So we're gonna save that. We're gonna rename this test.exe. We didn't do, okay. View. I can't remember how you do it. It's options, something to show file extensions. That's what we need. So here we just removed 2 bytes, and let's see if it's just literally adding null bytes to the end. So that very well might be it. Change settings. I'll show those for sure. Yeah, that did it. All right, so test.exe should run now that we've removed those 2 bytes. Let's see if it successfully removed them. Now it's 14 bytes, so now we might have actually screwed up. Let's run test.exe. Nope. Shit. Oh, that's annoying. So let's try cert util decode underscore enc.exe to testmal.exe. Let's run testmal.exe. Nope, that didn't work. So there's 2 bytes being added somewhere. This open for sure. Let's do in here. There's something adding those 2 bytes. PowerShell out file. It's PowerShell. Let's just do base 64 decode, adding 2 bytes. PowerShell. So it's so weird that it's literally just adding 2 bytes and that's breaking everything. All right, we're gonna switch gears a little bit. So I'm gonna pull up my notes. I'm gonna debug this PowerShell later. Let's see, how long have we been going now? 35 minutes. Switch gears at 35:43. So let's switch gears. We're gonna actually write some malware. So I'm not gonna worry about the PowerShell right now. And we're basically just gonna do the good old copy paste method until I figure out what's going on with that. So we're gonna be going based off of this right here. So we're going to enumerate processes. Let me go back to this and main.c. So our checklist right here, I guess I could drag this over. We're going to enumerate processes, we're going to create a network connection, and we're going to gather user information from registry. We've already been going for 30 minutes, so I'm going to save that for later. Save for later. All right, let's do this. So we're going to do the enumerate processes part first, and if you followed the series from before, you'll know that I've done this already in my previous version of the malware, but we're going to do things a little bit differently, and then it's actually going to be organized. So let's create a new file. We're going to call it processes.c. We're going to include windows.h, and we're going to do let's do carstar enum procs, and that's where we're going to start. So we also have to create, let's go ahead and do a make clean real quick. We can also kill our C2 because we don't need that anymore. And let's do a make clean. All right, so we can get rid of helper.c, and in our inc.h, which should be somewhere, includes.h, we're going to do carstar enum procs here. The main.c needs to includes.h. Now, this all should link together. Return a carstar casted void star. Does that not work? Can you not do that? Let's just do it this way. Void pointer, PTR, and cast pointer. Does that work? Yeah, that works. All right, so we need to change our make file now to that, and we need to do, let's see, it will end up being processes.o. So let's do a quick make. Nope, that didn't work. Oh, it's actually this. Oh, still looking for helper.o. Why is it still looking for helper.o? Definitely should not be. Main.o, processes.o. What? Oh, I bet I still have helper in there. No, I don't either. Huh. Where's helper at then? Oh, I bet I still have... Don't need this anymore. Let's go ahead and get rid of that. Let's do a make clean. Make again. Make on 11. What is it finding helper? Should be finding helper anywhere. Ah, that's where. Processes.o. Now we should be able to make, clean, and make. Golden. Now we've successfully not. Let's just go ahead and run main.exe. Alright, so it works. Now let's make sure that we've got it all linked correctly. Let's do include standard IL. Printf. Enum procs. That gone. Now make clean, make. A little bit again. Still works correctly, but I didn't actually run that. If we go to main, we can actually run enum procs. Make clean and make. Get it? Yep, okay. So, we are correctly linking everything, which in itself is a challenge sometimes. Now let's start actually enumerating the processes. Let's pop over to another window, since I don't have enough open already, and let's do msdn enum processes. So, Luca, if you're still here, this is me proving your point, basically. We're basically going to copy and paste a lot of this stuff from MSDN, and we are going to comment it. So we need a dword pointer to array that receives a list of process identifiers, size of the p process IDs array in bytes, the number of bytes returned in the p processes ID. So let's see if we can look at, no, I guess we can't. So let's just go ahead and give this a shot. So we need an LPID process. It's a dword pointer. Process. We need dword for count bytes. Let's just say 800 bytes. I don't know. And we need needed ones. That's just a pointer to a dword. This is actually wrong. P dword needed bytes. So let's just go ahead and call it. Or do enum processes. That didn't work. Oh, it's in this header. Well, Windows 8 should have that header. Let's see, PS API. Sure doesn't, does it? Why am I doing this? This might be part of the problem. Huh. I could have sworn that was lowercase Windows. Let's just go ahead and try include PS API. H. Now we should be able to get it. Enum processes, there we go. And enum processes takes in the LPID process. So let's go ahead and copy paste this into a comment. Go. So it takes that LPID process, takes CB, and it takes LPCB needed. Oh wait, no, I called it needed bytes. Let's see what it's gonna have an issue with. Oh, I didn't do everything right. Maybe I did do everything right. Let's do an F, enum processes. Except I don't think you can do it that way. Or it's at least going to show something weird. No, we need to print out lpid process. Here's where we're going to start running into issues with not having a debugger, or at least a debugger in the way that Visual Studio has one. Got some warnings. Sure that it will in fact, yeah, so it does create main.exe, so we can kind of ignore the warnings right now. Main.exe. Okay, so it's printing out a pointer to a D word. That pointer to the D word is going to be, if the function succeeds, the return value is non-zero. If the function fails, the return value is 0 to get extended information. So it should be non-zero. We can test for that pretty easily. If LPID process is not equal 0, if successfully gathered information, process information. Go. Make clean, make, run it. Yeah, so that is successfully getting that info. Now we just need to kind of figure out how this stores that information. Pointer to an array that receives a list of process identifiers. What are the identifiers themselves is the question. To determine how many processes were enumerated, divide the LPCB needed, divided by the size of D words. We can do that pretty easily. Number of processes running, percent D. We're going to do needed bytes. Might have to dereference it actually. Needed bytes divided by size of keyword. So that'll give us a number of processes. Let's actually go ahead and extract that out in an int. Int num_procs equal to that. It should return a clean integer. It might not though. We'll see. And let's see what else we need to do. Let's actually go ahead and run that, make sure that we're doing it correctly. Ooh, we had some kind of hang up. You see that? Yeah, we had some kind of error there. Maybe we don't need to dereference this. Let's try that. Yeah, no, that threw an error. LPD word, aka long unsigned int. No, long unsigned int. Yeah, you definitely do need to dereference that. We're gonna cast it as an int. See if it'll let us do that. I tend to doubt it will. Need to dereference it, then cast it. Looks like it's letting us, probably. Let's see. Nah, that's throwing an error somewhere. Well, let's see if it's throwing an error here. There it was, and error. So here, Shouldn't get anything printed out. Okay, so something's erroring, I'm assuming here. It's having an issue here. So let's not worry about this right now. Numprox divided by size of the word. This is actually needed bytes. Let's see if it works this way. Let's do make clean, make. Yeah, so it's having an issue with this division right here. Well, is it the division or is it the printing? And let's do procs again. Let's see where it's throwing the error. Because we don't have a debugger at the moment, we kind of have to do it the hacky way. Yeah, so it's this. Unsigned, I think it was unsigned long. Let's call it unsigned long. So that's a long D word. That we want to change this from a D word into a long. Let's see if that casting works. Hopefully it will. Did not. That's annoying. Let's try this. Needed bytes. And we'll just do needed bytes. That's not going to work because I didn't dereference. 0 needed bytes? Question mark? Huh. First PID. Just gonna do, what do we call it? LPID process. LPID process. Can you even do it this way? I don't think you can. Let's try it. Probably have to dereference that. Yeah, so that's PID, I think. 946. check one thing in the docs. So this is saying the number of bytes returned in the P process IDs array. That's over there saying 0. That ain't right. Something broke there. Yeah, something's broken there. So that's saying CB is 0, which ain't it. And if we look here, let's see. Look at the PIDs, which we may not be able to do here by default. Whatever. So we've got some issue here. It's a weird one. It's not actually writing out. CP is it supposed to be a pointer? No, it's not supposed to be a pointer. That's supposed to be a pointer. It's supposed to be a long pointer. That is. Huh. Oh, well, here's an example. Part of the problem is you're not doing this. Okay, so it's got to be a constant. Size 800. So that's going to end up being one of our problems. Size of A processes. That's another problem. So basically here, PID process. Basically there we were returning like the size of this D word, which is not right. So that's definitely that's an issue. That should work a little bit better, at least. Few bytes, 1 byte. Nope, that ain't right either. All right. So, we've reached another really interesting point in the stream. I've been going for an hour. And I haven't made enough process. So what we're going to do is we're going to end it here. And next stream, which will be on Friday, I want to say. Let me check. Should be Friday. Next one is November 3rd. No, it's tomorrow. Okay, so next stream tomorrow, I'll have working code, and I'll explain why it didn't work. I'm gonna play around with that PowerShell and see why it's not working, and then I'll come back with my findings. We'll almost turn it into like a live stream devlog. So that's how we'll do it. Disappointing, but it is what it is. Y'all take it easy. Peace.